Okay, now we can talk about a very important topic too. It's the students, how to have more students. We talked before about the lack of students and of talents on quantum. I think I can ask for each of you, how long have there been quantum courses in your schools and which are they? Maybe you can start, Sylvain.
Yes, thank you, Fanny. I think that as far as Institut Polytechnique de Paris is concerned, quantum mechanics courses and quantum courses have existed since the first principle and equations of quantum mechanics have been discovered. I looked into the archive at École Polytechnique and found in 1931, that's the first time that the name quantum mechanics has been mentioned in one of the courses. And today, and I think that's one of the specificity, because within the Institut Polytechnique de Paris, we are training engineers like French engineers that have a broad spectrum of knowledge. And I think that in 3 out of the 5 graduate schools from Institut Polytechnique de Paris, quantum mechanics is a compulsory course for all the students. So of course at École Polytechnique, 500 students every year take classes on quantum mechanics. At Télécom Paris, but also at ENSTA Paris. We don't have specialization in quantum optics, but all the students are trained in quantum mechanics, because we believe that it's a very fundamental knowledge that will be very useful in the future.
Thank you, Sylvain. Nicolas, in university?
Yeah, so I have to confirm what you say. Of course, it's the same at the Sorbonne University. So quantum physics itself has been taught for a very long time, and it's part of all bachelor and master programs. But maybe what was behind your question also is what about quantum technologies? And it's interesting to see that, I guess the same for you, about let's say the last 10 years, maybe a bit more, we started to see lectures specialized on quantum information, quantum metrology, and these different topics. And now, since the last, say, couple of years, you have specific master programs. So we have that in Sorbonne University or at École Normale Supérieure, so programs that join computer science people and physics people all together to teach new engineers. You have engineering quantum also at INS, and all these different masters are now popping out everywhere in France, I would say.
And Philippe, you start a minor and not a major, I think.
Yes. So first of all, we have a different approach, because EPITA, since its inception in 1984, is a kind of a different school. We are just focusing on training and graduating computer scientists. So most of what they do is software engineering and software development. And therefore we had started 3 years ago with Olivier Ezrati. I don't know if Olivier is still in the room. Olivier? Yes. So thanks to this guy, we started a minor in quantum computing 3 years ago. A minor is approximately a few dozen hours. So it was just for, you know, students who wanted to get the grip on the culture. But if you remember, you and I, several decades ago, I remember very well Steve Ballmer at Microsoft executing his monkey dance on stage. Do you remember that? And yes, yelling, developers, 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 because they were in need for talent to be able to deploy. And that's exactly what we have reflected upon last summer. And I was very, very cautious about triggering on the button. And then we decided and announced, actually at France Quantum a year ago, that we would drive quantum computing in major mode. And a major at EPITA is spanning over the last 2 years. And it's more than 600 hours of dedicated training on a specific topic, followed by a 6 months end of tuition internship in companies. And when I started to compare and to identify what was the landscape of other engineering schools, I'm talking about engineering schools, I realized that the most ambitious programs were usually in the 150 to 200 hours range, and were covering a large spectrum, including, of course, quantum physics. We here are focusing again on training developers. And we did that, and that's my last point, gathering around us in a mere 6 months, a group of 15 industry partners covering the whole French and European ecosystem, including, of course, the usual suspects like IBM and Microsoft and so on, who wanted to be part of it, so that our students are not only learning quantum software engineering in depth, but also are sure to stick to the industry needs and the industry standards. Because when you think about it, and you have exactly the same challenges, training students and preparing them to graduate as engineers in computer science is a challenge, because you need to bring them to what the state of the art will be 5 years after they join your school. And who in this room can predict exactly where will be the state of the art of software engineering and of computer science in 5 years from now? So we need to adapt, and the only way to adapt and to revisit the syllabus year after year is to make sure that you work with industry partners.
We can see we can really have a problem about the talents because we need researchers, we need teachers, we need engineers and startups. Do you have enough students actually in this course, and have you been able to see a positive Alain effects following his Nobel Prize? Maybe.
Yes, thank you. So indeed, so first, this is very true, we need arms. So we need people to work in the domain, would they be in research labs, would they be in startups or in big companies? That's a key issue. And that the main reason there was this teaching part of the quantum initiative, the French quantum initiative called Comté du France, that joined the 21 universities around in France, so that we bring people to a level where they can join industry and also do some continuing education that can teach to university, to industry, sorry. And then, yeah, do we have the people? So we see the effect. So it's not only Alain Aspect, even it's Alain Aspect indeed did a lot of publicity for the domain, but over the last 5 years, also the fact that you have many startups have a big effect on the fact that students are interested. And it's, from my point of view of a university, let's say, it's very nice because we have a lot of people that come and they want to do a PhD, and they know that after the PhD, they can engage or in industry career or academic career, depending on what they like. So we see a lot of people coming, but it takes time. And at the day of today, we lack still a lot of people, and we have to find a way to raise more. Because it's growing, I guess the same for you, but yeah, it takes time. So we need more and more initiative to bring people around.
Sylvain?
Yes, I agree with Nicolas. I think that it's before Alain Aspect, we have a long tradition of physicists, well-known physicists who encourage students through their courses to continue with a PhD in the various fields of quantum physics. So for that, the France 2030 gave us some extra funding to recruit more PhD students. We have also obtained more fundings to recruit more faculty members, especially young faculty members who would train the next generation of physicists. But as Philippe mentioned, we need also to train engineers because when you look at quantum technologies, you have to understand quantum physics, but you have also to understand all the applications and to understand about biology, chemistry. And I think that in France, we have this long tradition of training engineers that have a broad spectrum of knowledge in science. But do we train a sufficient number of students? The answer is no. I mentioned that we have every year 1,000 students out of 8,000 who have trained in quantum mechanics, but we have only 120 who are specializing in quantum technologies. So we need to increase that number, and we need also to train engineers and scientists who will not become specialists of quantum technologies, but to understand quantum technologies. For instance, we have majors in applied mathematics. When you do optimization, you have to understand how to optimize an algorithm for quantum computing. So we really have to look at the broad spectrum of to attract talent.
Yes, do we have courses for old engineers or people come from the code, or do we have this type of courses actually who start?
So I can answer, but I don't want to take too much of the time. The answer is yes. I think that's part of Comté du France. Nicolas mentioned that the objective was to train more PhD students. It's about 60% of the funding, but each of the 21 members of the consortium have also constructed new courses of executive education. And it's not only old engineers, but engineers that maybe don't have knowledge of quantum technologies. And at Institut Polytechnique de Paris, we're the first institution to have launched in March a comprehensive comprehensive executive education offer dedicated to quantum technologies. And for that, we don't do prêt-à-porter, we do sur mesure. We work with companies to help them to design the courses. And these are broad courses about the challenges and opportunities of quantum technologies for C-level executives, but also technical courses that will attract some companies in the fields of energy, in the fields of defense, and others.
Yeah, I mean, I think what you started with executive education is absolutely brilliant, because it's the only way to educate the future employers and to educate the future corporations to the fact that this is no longer pure science, this is no longer pure mathematics, this is not, so that's beyond an Aspen Nobel Prize. There are practical issues at stake that they need each of them in their companies to encourage. So that's brilliant. And to be honest, we are thinking with Axel Ferrazzini, our head of Quantum Major, to copycat what you've been doing, because this is a great idea and it needs more encouragements. Reflecting on Alain Aspect very briefly, Alain Aspect was already famous for his experiments in very cold atom freezing when I was doing my studies at the École Normale Supérieure. So it takes time from deep physics knowledge to Nobel Prize recognition. What is great about Alain Aspect's Nobel Prize is that nowadays science is back, or I hope it is, and Nobel Prizes are becoming stars. And that's very new, because before, I mean, there were just academic distinctions. It was in a few papers, but they were not promoted as being leaders in their discipline. So that's one thing. Answering your question about the size, again, when I decided to push the button, I wanted to be cautious. And also I wanted to leave the choice to students, because at EPITA, if there is no passion, there is no drive, and they won't learn. So we started with just 15 students, which means that they have a luxury program, because there are 15 companies, partners giving lessons, as well as 15 students, so they are very, very well cocooned. Are there any EPITA Quantum Major students in the room? Okay, these are the guys you need to talk to at the break, because they are the future of quantum programming. You need to talk to them and to meet them. And are there any of our partners in the room? Are there any companies, partners of... They are lazy guys. Ah, yes, one, but very, very shy. And the other person you need to talk to is Axel Ferrazzini. There are probably corporations that we... But of course, if you want to reach scale, you need to increase the volume of students. And given the reputation that the Quantum Major already has within the schools, I'm sure that among the 600 students who have to pick their major in a few weeks from now, we should reach 40 to 42, which is our magical number. We should reach 40 students by next year.
Okay, a last question. Is quantum attracting the best talents when you are a company? To have a few talents attract others and can be a good things for the company?
So yeah, so you're asking if really quantum still attracts the best student. It's kind of true. It's not always true. Huh? Like if you look at let's say ENS, which is where the best students go, sometimes they are still a lot attracted by theoretical physics. So we need to bring them back a bit to quantum. But it's still, because of the reason we mentioned before, it's a new for fundamental science, because it's a field now which is building in collaboration with industry. So it's a rare effect we have in France, because usually these things are completely separated. So the fact that quantum technologies are building, and the curricula are building with companies, with startups, attract a lot of students. And then you have to define what the best students are.
No, it's not students, but talents. To attract talents in your company, to have to have, yes, a team about quantum in your industry, in your company, can be attract other talents, even if they never start quantum, actually.
So I will not answer for companies, because I'm not doing that, but I want to insist and tell the others. something very important is to what you said, to bring talents which are not doing fundamental physics. We should, let's say, demystify quantum physics. And that's very important, even though much as I like Schrödinger cats, we should stop saying that quantum physics is about Schrödinger cats because it scares people. And every day, daily quantum physics is not about that. So this is something we should learn as academics to teach, to bring other talents to industry.
Do you want to comment?
Yeah, I mean, there is one obvious field where companies are already attracting quantum skilled engineers, which is security at large. Most banks I know of are very, very heavily investing in and picking talents in post-quantum cryptography. So, which means, and which is interesting because it shows that quantum is actually at the convergence between several areas, including cybersecurity, including AI, as well as telecommunications. Some of you probably saw this morning the press release we announced with Qualcomm on telecommunications and quantum communications. Qualcomm is partnering with EPITA on that very topic. And so each time you're looking for a different type of talent, a different type of engineer capable of programming in totally different paradigms, while still keeping focus on your emergencies and your issues for today, again, cybersecurity, AI, telecoms, then you might attract interesting profiles, provided that you let them grow, provided that you develop them, and provided that you're capable of keeping them. So that's a message for the corporations in the room. That's a good thing to attract talent. The most difficult part is after retaining them.
Thank you very much, three of you. And I think Ethan can conclude the morning. Thank you very much.
Thank you.